Hello everybody, it's Mrs. Prickett. I am so excited to be able to join forces with your teacher today to do some really cool investigations with matter. You've been working really hard as scientists to learn all about matter and all the important information that goes with it. So before we dive into something new today, let's go back and review to make sure we're holding on to all that important information, okay? So what is matter? When we're talking about matter, what does that even mean? Who can tell me? Think about it. That's right. Matter is anything in this world, right? But it has to have three things. What are the three things that all matter has or can do? Who remembers? That's right. Matter has mass. What else? It has density. Good. And what's the last thing? That's right. All matter takes up space. Takes up space. Now this is going to be our focus today on how matter takes up space. We're going to talk a little bit about that one, about how it also has mass, but we're going to save density for another day, okay? So before we get into something new, let's talk about what we learned about how matter takes up space when we're talking about solids and liquids, because those are the things that you've already learned and you're experts at by now, right? Okay, so what makes solids unique or special or different from liquids and gases and how they take up space? Do you remember? Think about it. That's right. Solids keep their shape. They hold on to their shape no matter what container you put it in, right? So solids keep their shape, right? If I take this roll of tape, put it in a drawer, it's going to look exactly the same as it would if I put it in a backpack or if I put it in the cup holder of my car. It's going to always look this size and this shape unless I do something on purpose to change it, like smash it or break it or something like that. So solids keep their shape. That's what makes them unique. What is it about liquids and how they take up space that makes them different from solids? Who remembers? This one's a little bit newer. We've talked about it a little bit less. That's right. They don't keep their shape, do they? They take whatever shape of the container is that they're in, right? So liquids take the shape of their container. So my water that I'm drinking here in my Yeti, right now, it's Yeti shaped. But if I poured it into, say, this cup, it would be a little bit different shape. Or if I poured it into a cereal bowl, it would be a different shape. It's not going to just stay like this if I put it into a different shaped container, right? It's going to take whatever the shape is of the container. All right, so now today we're going to talk about gases, and I'm so excited because these are some pretty cool demonstrations that we're going to be doing that are going to show exactly how gases take up space, and we'll even talk about how we can prove that they have mass. Now, I know you might be thinking, wait a minute, Mrs. Prickett, how are we going to figure this out if we can't see gases? And you're right, we can't. We've got gas all around us. The air that we breathe is a gas, but we can't see it. So we're going to have to be really creative scientists when we do these demonstrations so that we can see and prove and find that evidence that we need to support our claim that gases really are matter. Okay. So first things first, gases take up space. That's what we're going to prove. All right, so gases take up space, which solids and liquids do, but they have to do it a little bit differently than solids and liquids to make them unique. Remember, solids keep their own shape. Liquids take the shape of their container. I wonder what gases are going to do. So I'm going to use the gas of my breath and see what happens to it when I put it in this square container. Okay, are you ready? Watch closely. Whoops. Did you see that? Now it's full of air. And is the air just down here at the bottom? No, that's right. It filled this whole square baggy space, right? It's all full of air. So I wonder what's going to happen when I put my air, my gas, into this glove. I wonder. Make your predictions before I blow into it, and let's see. Are you ready? Here we go. See that? It took the shape of this rubber glove. And is it all just in one finger or in just the bottom part of it? No, that's right. It filled the space of this rubber glove. Isn't that neat? So keep that in mind, those two things that we just did, and think about when you've ever seen or blown up a balloon. What's going to happen? Make your prediction. What do you think? You think it's going to look like it did when it was in the glove? No? You think it's going to look like it did when it was in the bag? No? All right, let's see. Are we ready? All right, here we go. Filled that space, didn't it? What if I add more? Is it going to stay right here? Let's see. Oh my goodness, it filled that space. No matter how much or how little I put in, that gas, that air is going to expand and fill the space. Isn't that fascinating? All right, so real quick, let's talk about what we just learned. We know that solids keep their shape. Liquids take the shape of your container. Gases also take the shape of their container, but what else do they do? That's right, it fills the space of their container. So gases fill the shape of their container. That's what makes gases unique in how they take up space. All right, so now we know that gases take up space, right? And they supposedly fill the space of their container. I want to show you a really cool demonstration here. It's still going to prove that gases take up space and fill their container, but it's almost like magic. Now, if you've ever seen some cool magic tricks, we know magic's not real. Most of the time, it's really science. That's what makes science so cool. Okay, so you can see here I've got this tub of water, and I've got 2 styrofoam cups. They're identical. I'm just going to make one quick change to one of the cups. I'm going to poke holes in the bottom of one of them. Like that. See? Got holes poked in the bottom. But other than the holes, they're the exact same cup. The holes are the only difference. Okay, you with me so far? All right. And then I've got these 2 identical wash rags. All right. I'm going to put one inside the cup with the holes. See, there's the holes. And I'm going to submerge this cup into the tank of water. That means I'm going to put it all the way down below the surface of the water so that it's totally covered. Okay? So, here's my rag in my cup, and I'm going to submerge it. I want you to predict. Make a hypothesis. What do you think is going to happen when I put this rag in the cup in the water? Are you ready? Let's see. Watch closely. All right, it's totally submerged. Do you see that? All right, I'm going to pick it up. Oh no! The rag came out and it's totally wet. I wonder why it did that. You might be thinking it's gravity. I don't know. We'll see. So I'm going to do the same experiment with this cup. It doesn't have the holes in the bottom, right? And the same identical rag, only this one is dry, right? Shove it down in there. You can see it's not falling out. The other one didn't fall out either, so it can't just be gravity. So let's see what happens. I'm going to totally submerge this cup too. All right, let's watch. Totally submerged. Can you see that? All right, I'm going to pull it back out. Oh, the rag is still in there, and it's totally dry. Look at that. Can you tell the difference between this wet rag? It got darker, and this dry rag? All right, I wonder why that is. I really want you to think for a minute about why the rag that was in the cup without the holes was able to stay dry, and the rag in the cup with holes got wet. Think about it for a minute, because they both got totally covered up by the water. So what is it that made the difference? All right, do you have any ideas? All right. Now I'm sure some of you are saying, well, this one had holes, so it let the water get in. And you know what? You're absolutely right about that. The water went into the holes, but what had to happen in order for the water to be able to go into the holes? I wonder. Keep thinking about that. So this cup did not have holes, right? And we put it all the way under. But why didn't it get wet from the water that was already inside the container? Think about it. Because was this really just a cup and a rag? Or was there something else inside? That's right, it was full of air. So even though the rag, the solid rag, was only taking up that much space, right? The rest of the cup was full of air. So when I put it down into the water, there was no room for anything else to get in. But this cup that had the holes in it, the holes let the air escape, which made room for the water to get in. So as long as the air was trapped inside, it was taking up all the space that there was in that cup, and there wasn't room for any of that water. But as soon as we made room for the air to escape, then there was room for the water to get in. So this is not really just a cup with a rag in it. It's a cup with a rag and air. So air definitely helped take up the space to keep this rag dry. Pretty neat, huh? Okay, one last investigation. This one is going to prove that gases do have mass. So remember, when we're measuring mass, we have to use a balance. So I've kind of made my own little balance here. So I'm going to just hang it up right here, and we're going to try to situate it so that the ruler is level. So I need to move it just a little bit. Oops. About like that? Does that look about level? You can see if I can move this so you can see everything. I'll have to move the camera, I think. Let's do that. Okay, there we go. So now I need to move my ruler. There we go. That looks like it's about level. All right. I've got one balloon already blown up. I'm going to take a second balloon and I'm going to blow it up, and I want it to be like the exact same size as this one, or at least as close as we can get it. So let's see if I can do that. Is that good? Ooh, it's pretty close. But I think this one needs a little bit more. Let's see. All right, that looks about equal to me, okay? So now we've got two balloons that are the same size. I'm going to put them on the opposite ends of our balance. And let's see if I can get it to balance once my balloons are attached here. Sticky tape. All right, so here's one balloon on one side. And let's put this balloon on the other. get it taped on there. All right, let's adjust this a little bit, make sure it's balanced. Okay, that looks like it's balanced to me. All right, now, this experiment with mass is a little bit different than some of the others. We're not actually going to be able to measure how much mass the gases have, because if I had a cup full of air and I put like one paper clip on the other side, that paper clip would already be heavier than the cup of air, right? So we don't have any tools, especially not here at my house or at school, that will help us measure how much mass a gas has. So this activity is really just going to prove that gases do, in fact, have mass, okay? So now what I'm going to do is I'm going to let the air out of one of these balloons. So we'll end up with one balloon that is full of gas and one balloon that's empty. Now I want you to think and I want you to predict. If gas has mass, what's going to happen to this balloon that has the gas still in it? Is it going to have more mass than the balloon that's empty? Or is it going to have less mass? What do you think? That's right, it should have more, because if gas has mass, then something full of gas should have more mass than something without gas, right? Now, how are we going to be able to prove that? If something has more mass than something else on the balance, what does it do? That's right, it goes down. So if I have a cup of water on this side and nothing on this side, the cup of water has more mass and it's going to go down. So that's what we're going to look for to happen to this balloon if it's going to prove that gas really does have mass. If gas has mass, this side should go down while this side goes up. Right? Are you with me? All right, so I'm going to see if I can take the air out of this balloon. Oh, the air's coming out. It's coming out, getting smaller and smaller. You see that? All right, and the air's going out, and the air's going out, but look what happened to our balloon. Do you see that? The one that's full of gas or has more gas, it has more mass than the one without. So we have proven today that gas has mass, and we've proven that gas takes up space. Not only does it take up space, but it fills the space and the shape of whatever you put it in. This cup right now has a rag in it, but the rest of it is full of gas. If I take this out, is that an empty cup? No, not really, because it is full of gas. And this plastic baggie is now full of gas. The gas doesn't just stay at the bottom or go to one corner, it fills the shape of the container that you put it in. So, we've learned lots of cool things about matter, and I really enjoyed showing you these investigations. If you like them and have permission from your parents to use some of these materials, you can test to see if you can make sure that gases have mass. Or you can do the trick with the cups and poke holes in one of them and see if you can impress your friends and family with something that seems magical but is really just science. Great job today, guys.